Okay, so this is the explanation video for the common ion effect worksheet. And like I said in class, if you haven't done the second question, if you haven't even given it a shot, I would really recommend that you actually do spend some time trying to figure that out. I did give you the answer in class. The answer is the pH will be 1.78 for the second part of this, the last question. So if you haven't, done it yet, just one last plea to actually try it first before you look at this video. For those of you who have done it and just want an extra explanation, great. What I'm showing you here at the beginning is just solving the top part. This is a simple weak acid Ka type problem. I've written out my equation here. Again, always want to be starting with that chemical equation. Written my Ka here. I've got an initial concentration of acetic acid, simple ice table, solve for X. This is negligible here, and that's going to be my concentration of H+, which I use to find my pH. But then this is also my concentration of acetate ion. So normally, to this point, we've just been concerned about concentration of H+, but now we're going to start talking about these other ions and what's sort of happening in solution with them. So this is the ion that we're concerned with for question number 2. What's going to happen if I add HCl? That's a strong acid, that's a source of H+. So if I add H+ or H3O+, what I'm really looking at is this equilibrium here. What's going to happen to this? If I add in more H3O+, how is this equilibrium going to shift? How is it going to react to that perturbation? So Le Chatelier's principle says if I perturb the equilibrium, if I add more H3O+, the equilibrium will react in such a way to offset that perturbation. So add H3O+, that's going to shift the reaction to the left. I'm going to consume some of this acetate ion, reforming water and acetic acid. So I should expect that the concentration will decrease, right? So just make sure that we're all on board with that. Okay, so for the next part, the first thing that I've done is calculate the new molarities. And this is just, sort of going back to Chem 122, Chem 121, taking a volume and a molarity and finding the number of moles. And then using the new total volume, so here I've got 50 milliliters plus 10 milliliters, that's going to be a new total volume of 60 milliliters. The new total volume to find the new initial molarity. So here for acetic acid, I can say that my concentration is equal to 0.005 moles divided by 0.06 liters. That gives me this 0.0833 molarity for my acetic acid. I've done the same thing for H3O+, taking this initial 10 milliliters, 0.1 molar, so 0.01 moles, divided by the new total volume to get me to these initial values. So what's a little bit maybe strange about this is we're saying that these are our initial values when, earlier we said that we solved this for our concentration of H3O+, our concentration of acetate ion. And in the second part, I'm saying if I add that H3O+ in, the reaction is going to shift back to the left. So in terms of solving the ice table, it's a little confusing as to how we're sort of going to go about solving the ice table. But as it turns out, the easiest way to handle this, easiest way to do this, is to set up our ice table as per usual. And again, really important that we're just using a normal looking Ka type equation. I know a lot of us were writing in some more complex chemical equations, chemical equilibriums, but this is really all we really need. So I'm just going to write in my initial values, and here for H3O+, now I've got an initial value of 0.0167. So now at this point, I'm initially saying, I'm sort of, to solve this, I'm sort of going about it a little strangely, right? We're saying we are going to start with 0, and then we're going to see how far this reaction goes to the right. Oops. Minus x plus x plus x. In my change line, right? And this plus x value, that's going to be my new equilibrium concentration of acetate ion. Again, we're going to be tempted because up here, right, we said this reaction is going to the right. Here, we're saying that this concentration should decrease. So we're going to be tempted to sort of do this in a different way, but The reason we're doing it this way is just it makes solving a lot easier, and it makes solving for this x value, you know, a little bit easier. So we'll talk about this more in class, but again, this is the way to solve this. At this point, now I'm just basically solving my, you know, normal ice table. And in this case, both of these plus x and minus x terms, they're both going to be negligible, right? I expect this x value to be very, very small because my Ka is very, very small. I can do that same test, right? It's still initial values divided by the Ka, if that's big enough. But also, you know, we'll want to compare what our x value is to these values here to see if it is significant or not. So if you go ahead and solve this, treating these as negligible, your x value comes out to be 8.5 times 10 to the minus fifth. And that is going to be our concentration of C2H3O2 minus, right? So x here plus x, that is my concentration. So at this point in time, what I would want to do is compare this value to what we came up with originally, right? Originally, we said that our concentration of acetate ion was 1.3 times 10 to the minus third. In the second part, we said that it should decrease. And now we've got a value of 8.5 times 10 to the minus fifth. So that makes sense. That's good. Now our concentration of H plus, right, that's really just going to still be 0.0167, right? Because that 0.0167, that has said, you know, plus x, where x is very small. That's not going to change this at all. So that's where we get our pH value of 1.78, actually. So in terms of solving for the pH, we really didn't need to do any of this ice table stuff. I think it's good just to practice and to sort of show us that. The pH is just going to be dependent on the concentration of H plus, you know, that we've added to the solution. Obviously, this is going to be case by case, so don't take that, you know, and run with it. But, you know, really think about what are the species in solution, what's going on with those, how are they going to interact with one another, and how do we actually solve for this concentration of acetate ion. All right, if you have any questions, obviously let me know. And if you have any feedback on how I can make these videos better, also let me know about that too. Thanks a lot.